Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the third question from the media examination which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos since the question paper had 7 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Okay, we are told that an investigation is carried out to determine the effect of branching on the boiling point of organic compounds. 3 primary alcohols that each contain 5 carbon atoms are used during this investigation rather. Equal volumes of each alcohols are heated separately in water. Okay, these alcohols are such that the first one guys is just a straight chain alcohol, primary alcohol, that will simply have a hydroxide ion at the terminal carbon. The IUPAC name of this alcohol is called pentane 1-ol. 1, 2, 3, 4, 5. It's pentane 1-ol. And then the other alcohol that you might have, it's methyl. Let's have a side chain over here. The other alcohol that we have guys, it can be 2-methyl butane 1-ol or 3-methyl butane 1-ol. 3-methyl butane 1-ol. In our case, let me write the IUPAC name. It's 3-methyl butane 1-ol. And then the third alcohol that we have, it can be dimethyl propane 1-ol. It's dimethyl propane 1-ol. So all of these alcohols guys are just chain isomers of one another. Let me indicate the alcohol with the blue color, just to show that the alcohol is on the is on the last carbon, or at the terminal carbon. The position of the alcohol of the functional group is the same. The only difference guys is the chain length. Are you together? The only difference is the chain length. So I'm expecting this one to have the lowest boiling point. Why? Because it has a lower surface area compared to the other two, and I'm expecting this one to have the highest boiling point compared to the other alcohols, because it has more surface area, or a larger surface area compared to the other two alcohols. Are you together? So this alcohol over here, the pentane 1-ol, will be alcohol 1, because it has a higher boiling point, right? And then this will be alcohol 2, and then this one will simply be alcohol 3, because it has the lowest boiling point. The organic compound that is more spherical, or the one that is more branched, is the one that will have a lower boiling point. Okay, now let's answer these questions guys. Define the term boiling point. Boiling point guys is a temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. The vapor pressure of a liquid is equal to the atmospheric pressure. Okay, what property of alcohol requires them to be heated in a water bath? They need to be heated in a water bath. Why? Because alcohol is highly flammable. Are you together? You can say it's flammable, or you can say it's highly volatile. So alcohols are just flammable. Okay, and then now I must write down the boiling point of alcohol 1. The boiling point of alcohol 1 is over here. I can see that I have this number is 120, 130, 140, and 150. So the temperature is just 140 degrees Celsius. Okay, and then now we are being asked, is this a fair investigation? Right, yes or no? Give a reason for your answer. Yes, it is a fair investigation. Why? Because the molecular mass for all these three alcohols is the same. Are you together? They have the same molecular mass. Okay, and then now you must write down the IUPAC name of alcohol 2. Alcohol 2, guys, as I did mention earlier, it can be 2-methyl-butane-1-ol or 3-methyl-butane-1-ol. Yeah? So alcohol 2, others can write 2-methyl-butane-1-ol. And then others may prefer to write 3-methyl-butane-1-ol. Okay, and then which alcohol has the shortest chain length? Alcohol 1, 2, or 3? Alcohol 3 has the shortest chain length. Why? Because it has a lower boiling point. Since it has a lower boiling point, that means it has weaker intermolecular forces compared to the other two compounds. Are you together? So alcohol 2, the answer is just alcohol 3, ne? Okay, alcohol 3. And then the reason behind, you'll simply say that alcohol 3 has a lower boiling point, and therefore it has it has a lower boiling point, né? Okay, and then the next point will simply say, therefore alcohol 3 has weaker intermolecular forces compared to the other two alcohols, and hence we need less energy to separate the bonds, less energy to separate the bonds, and that's why alcohol 3 has the shortest the shortest chain, rather. Excuse me, guys. Alcohol 3 has the shortest chain because it has a lower boiling point. That means it has weaker intermolecular forces compared to the other two alcohols, and hence there's less energy required to separate the bonds of alcohol number 3. Therefore, alcohol 3 is the one that has a shorter chain. You can say it has a shorter chain, or you can simply say it is more branched than the other alcohols. Okay, and then now we are told that a second investigation is carried out to determine the effect of intermolecular forces on vapor pressure. Okay, the table below summarizes the results from the two organic compounds. You have butanone and butane-1-ol. Ne? Compound A is a ketone. Compound B is an alcohol. An alcohol, guys, has stronger intermolecular forces compared to a ketone. Are you together? If your compound has stronger intermolecular forces, it will have a higher boiling point and a lower vapor pressure. As you can see there, guys, ne? For alcohols, the vapor pressure is smaller, but for ketones, the vapor pressure is higher than that of alcohols. This shows that ketones has weaker intermolecular forces compared to alcohols. Ne? Already, guys, there's a video that is being uploaded. Please go there and check. First question, they want us to define the term vapor pressure. They want us to define the term vapor pressure. Né? Vapor pressure, guys, is just the pressure exerted by a vapor at equilibrium, at equilibrium rather, with its liquid in a closed system. The pressure exerted by a vapor at equilibrium with its liquid in a closed system. Né? Okay, and then now you're supposed to explain the difference in vapor pressure by referring to the intermolecular forces. Okay, we can differentiate these two compounds, guys, by making compound B the reference, or you can simply make compound A the reference. It's definitely up to you. Now, let's make compound B as our reference. Okay, we'll simply say butane 1-ol has hydrogen bond. Né? So therefore, butane 1-ol have stronger intermolecular forces compared to butanol. Are you together? And hence more energy will be required to separate the bonds of butane 1-ol, and that's why butane 1-ol will have a higher boiling point and a lower vapor pressure. Therefore, butane 1-ol will have a lower vapor pressure. Are you together? That's how, guys, we're supposed to contrast the two by using butane 1-ol as a reference. Né? But if you wanted to use, guys, butanone, our ketone, you could have said that butanone has dipole forces between the bonds, and hence butanone has weaker intermolecular forces compared to the alcohol that you have, which is butane 1-ol. And then you simply say less energy is required to separate the bonds of butanone, and hence butanone will have the highest vapor pressure compared to the two compounds. That's how, guys, we're supposed to tackle that question. Okay, will the vapor pressure of the above compounds increase, decrease, or remain the same at a higher temperature? At a higher temperature, guys, they will increase. Are you together? Because if you increase temperature, you're also increasing the vapor pressure, the vapor pressure of your substance as well. Remember that boiling point by definition is a temperature at which the vapor pressure is equal to the atmospheric pressure. So if you increase the temperature, that means the atmospheric pressure will increase, and hence the vapor pressure will also increase. That's why the answer over there will simply be increase. That's how, guys, we're supposed to tackle that question over there. So please do stay tuned and wait for more videos. Thank you.